Hello everyone, this is chapter 10. In this part, I am solving questions 19, 20, 21, and 22. Let's get started. So in question 19, it says for the short run cost function, AVC, average variable cost, A plus B, Q plus C, Q raised to the power 3. This actually corresponds to a cubic cost function. Why? Because total variable cost, which is Q times average variable cost, is going to look like this: AQ plus BQ raised to the power 2 plus CQ raised to the power ding 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 3. This is cubic form. Okay, but the question is not asking that. I just want to insert some information while we're at it. So for this to have appropriate properties of average variable costs dollar, to have U-shaped and convex shape, you have to have A to be positive, this A to be positive, B to be negative, and C to be positive as well. I do derivation of these in my lectures. You don't have to, know these derivations. You can simply memorize it, okay? This is the correct one. This is wrong. A is negative. Nope. A needs to be positive. Okay, so the corresponding marginal cost function is this. Okay, so to find the marginal cost, to check if this is, so I know B is correct, A is not correct. Both A and C definitely by default is not correct. But what if, all of the above is incorrect, because one is definitely incorrect. So to find, SMC, you got your answer B. However, if you want to find also marginal cost, this is the first derivative of total variable cost with respect to quantity. So it's going to look like A plus B Q raised to the power 2. 2 comes up from 2B. Q power 2 minus 1, 1 plus 3. Derivative of this with respect to Q is 3C Q raised to the power 2. So is it what we found? Let's see if it matches. So A, first of all, marginal cost doesn't have AQ, it only has A, so it failed already. But 2B Q raised to the power 2, no, it's 2BQ. 3C, okay, that matches, but Q raised to the power 3, it doesn't match. So the correct answer is B. Okay, next question. Let's get rid of this. Next question, number 20. It says when estimating, let's just, hold on. Let's just grab this and delete. Boom. Okay. So question 20. When estimating a cubic short-term production function, okay, using linear regression analysis, what we do is we turn this L raised to the power 3. We call it like L3, or you can call it anything. You can call it Karen. Of course. You can L2 is, I don't know, Jamie. I just make up names. Karen reminds me of something else. But, okay, so you can call it whatever, but usually in the transformations, we call it L3, define a new variable we created, right, in the PowerPoint slides. Transform the equation into linear form by defining L2, L3 is L raised to the power 3, 2. And here you gotta suppress the intercept, remember? Because we can't have intercept here. Convert the right hand sides to logarithms. No, you don't need to convert the logarithms, because it's not like L raised to the power A or something, okay? So we don't need to, or like it's 3 raised to the power L. So you don't need to do these, right? So it's A and B are correct. Correct answer is D. Okay, question number 21. Alright, this is a cool question. It asks me, given this quantity, this output function, long run production function, this is also total product, right? Suppose that the firm employs 12 units of capital. So I know capital is 12 units at blah blah units of labor. We're trying to find labor such that marginal product begins to diminish. In other words, I'm looking at the maximum point of marginal product. Okay, what is the L? Remember L, labor that gives the maximum product of maximum point of marginal product beyond which it starts to diminish. So the formula was, it is negative b over 3. It's negative b over 3a. Okay, what is a and b? So it is actually q equals, remember, a raised to the power 3 plus b L raised to the power 2. So I need to find this a and b first. Then I'm going to plug into this formula. Okay, so a here is right here. This whole thing is my a. Okay, so it's negative 0.0075 times k is given to it 12 raised to the power 3. Okay, what is b? Again, b is right here, the coefficient estimate of L raised to the power 2. So it's 12 times 12 raised to the power 2. So this is 12 times 12 times 12. It is 1728. And this one becomes negative 0.0075 times 1728. Okay, so if you make this calculation, you're going to get negative 12.96. Okay, now I got my A. Great news. I got my A and I got my B calculated. So let's find LM, the point at which marginal product starts diminishing. It's negative B, negative 1728 divided by 3A, 3 times negative 12.96. Okay, so what is this? LM, right? Negative 1728 divided by, this is going to be negative again, 3888. Negatives cancel out. So if you calculate this, you're going to find 4444. Okay, so the correct answer is B. Let's take a look at the last question. So the same function, average product when 10 units of labor are employed is. Okay, so let's grab what we found, right? Let's actually, I'm just going to write it down. Quantity, right? A L raised to the power 3 plus B L raised to the power 2. So that was actually 12.96 plus, right, 17, L raised to the power 3. Let's make a different color actually. L power 3, and this is L raised to power 2. Go back to 1728 times L squared. So I plugged in A and B. This is A and B. So what's average product? Average product is total product. So this is my total product, quantity divided by labor. So divide this by L, 12.19, L raised to the power 3 divided by 1L, L squared, plus 1728, L raised to the power 2 divided by L, just L itself. So this is my average product. What am I asked to do when 10 units of labor are employed? Okay, cool. So this is 10 times 10, 100 times 12, 12.96 is 1296 plus, this is 10. If you calculate 17,000, this is a negative sign. Don't forget the negative sign. Look how I did. Even a professor can't forget the negative sign. What does it tell to you? That means always write things down. Do not just plug in everything in your calculator, right? This is your calculator. Don't just calculate things on your machine. For sure have a scratch paper and double check. Oh, what was it in the previous question? Okay, there was a negative sign here. Hello. So double check, go back. These kind of mistakes are done, but I always wake up. It's 17,280 minus 1,296. The answer is going to be, if you calculate 15,984 units. That's the average product, and it concludes this chapter. So in this chapter there are a couple of more questions that I didn't answer. However, given what I taught you and given our coverage, you can easily do the other ones. And that's it.